Assalamualaikum. My name is Muhammad Zahri bin Zainul Syam and my metric number is 200929.
My name is Ligeshwar Murugasu and my matrix number is 203701.
My name is Muhammad Adam bin Kamaruddin. My battery number is 200901.
Hi, my name is Wana Sharina binti Muhammad Zaki. I'm going to present to you guys about the thermodynamic application. The application that we choose is ice maker.
So this is how the ice maker gonna looks like from the front view and back view.
Now I'm going to explain about the first law of thermodynamics. First law of thermodynamics is known as law of conservation of energy, where it states that energy cannot be destroyed or created, but only can change the form of it. Okay, the application that has the first law of thermodynamics is compressor, where when the power supply is connected, the electrical energy from the power supply is converted to heat energy in order to increase the temperature of the refrigerant. Apart from compressor, evaporator also uses heat energy to reduce the temperature into so that it can be made into ice cubes.
Thank you, Lingesh. Next, I would like to explain about the second law of thermodynamics. So, as your general knowledge, second law of thermodynamics is that the energy has quality as well quantity, and the actual process occurs in the direction of decreasing quality of energy. So, it will indicate occurs in the refrigeration cycle, which involve when high temperature will occur when receive it, and to the lower temperature when it reject the waste heat. So, for example, in our application of ice maker, there is device called as evaporator or known as heat exchanger. So, that in evaporator, there is increased amount of heat transfer in the region causes the decreasing amount of heat transfer at the outlet region. So, unfortunately, the heat energy will absorb into the refrigerant ducts and cause the water to be freeze by reducing its temperature. So the ice will be formed. So I think that's all for me. Thank you.
So for my part, I'm going to present about the analysis of compressor. So actually, compressor act as a heart of the refrigerant system because it control the flow system through the ice maker. So first thing that compressor do is to suck the refrigerant with a low pressure from the devices before in a vapor state, and then it will discharge the refrigerant in the higher pressure and at the same time at the higher temperature. So inside the compressor there is a piston and discharge valve and also a suction valve. I will show you a short animation about the compressor. Okay, for energy balance equation, as we know, energy cannot be destroyed. So total energy inlet equals to total energy outlet. And it is in a steady flow. As we know, we need a power supply to turn on the compressor. And then, of course, we need a power supply. And if there is a Q loss, then we need to put the Q loss into the equation. So kinetic energy is equal to 0. Why? Because the velocity is same because of the surface at the inlet and outlet is same. And also for the potential energy is equal to 0. Why? Because the location of the inlet and outlet is same from the top of view. And then the final equation is equal to W in is equal to M dot Q loss plus M dot H2 minus H1. By the way, M dot inlet is equal to M dot outlet because of there is only one inlet and one outlet. So move on to the condenser. So how condenser work? Condenser work to cool down the refrigerant temperature because the compressor pass the refrigerant in a high temperature and in the saturated vapor state, and then condenser work to turn back the vapor into the normal state, which is liquid refrigerant. So that's why it was condenser was put at the back of the ice maker so that there is a heat transfer happen. That's why the atmosphere, there is a heat transfer between the coil at the condenser and the atmosphere. We can feel heat behind the ice maker. So for the energy balance principle, energy inlet equals to energy outlet. We can cancel out Q and W and also the kinetic energy and also potential energy. We can Q. The highlight from the condenser is we need to categorize the M dot based on the substances, which is air and refrigerant. So from, as you can see here, MA is indicates for M dot air and MB indicates the M dot refrigerant. So the final equation is equal to MA bracket H2 minus H1 equals to MB H3 minus H4.
Thermostatic expansion valve. Thermostatic expansion valve is used to reduce the pressure of refrigerant from condenser pressure to evaporator pressure. When the refrigerant leaves condenser, it is in high pressure. So in order to go to evaporator, it need to reduce the pressure and its temperature. So that the thermostatic expansion valve is used in reducing the pressure and to evaporator pressure limit. Okay. Apart from that, thermostatic expansion is also used to keep evaporator active, where it allows the flow of refrigerant as per the cooling load inside the evaporator. So when the cooling load is higher, it allows higher amount of refrigerant to the evaporator. When the load is lesser, it it allows less amount of refrigerant to the evaporator. Okay, the analysis energy balance equation. Okay, since the it is flow in the steady state, so the inlet and energy outlets is equal. So there is no heat loss or work or heat. So therefore, yeah, therefore the enthalpy for inlet and outlet is equal. Thank you.
Hi, welcome back. Thank you, my friends. So I would like to explain about the hot gas valve. So for the description, the hot gas valve is functioned to stabilize the system balance point by allowing hot high pressure of the refrigerant vapor from discharge device that flow directly to the discharge device at the low pressure. So it is considered as a similar function to the throttling device, which is function to restrict the flow of fluid and cause the significant pressure drop. So it is actually to conduct the flow of refrigerant from the compressor to the evaporator. So this one is the rough sketch of the throttling device from region 1 and in the 1 and to the outlet 2. So next, I would like to explain about the thermo, thermo, thermodynamic analysis of the hot gas valve by using the energy balance principle. So by using the final equation is H1 equal to H2, which is we can found by using the formula of energy balance equation. So since we assume the flow of system is steady, so there is no energy is at the outlet equal to energy in inlet. So then second assumption, we consider there is no heat transfer or work done. So we assume that into zero. But then there is also no potential energy or kinetic energy so involved. So we assume that equal to zero. Next, we consider mass flow rate at the outer region and inlet region is same. So we just cancel it. And then the left is H1 equal to H2. So I think that's all for me. I will pass to my friend. Thank you very much.
Evaporator grid. Evaporator grid is one of the main device in ice machine, which it act as like heat exchanger. So to produce ice, latent heat need to be absorbed through a refrigerant in order to reduce the temperature and pressure of the water. So when it enter the freezing temperature limit, ice cube are produced. Okay. After once the ice cube is frozen enough, so it is harvested. The harvested cycles occur where it collects the ice cubes from the storage bin to uses to be used. Okay, so energy balance principle. So the energy balance principle, there is energy. Assume that it is in steady flow. When steady flow, energy inlet is equals to energy outlet. So there is no work done by there. So no work in or work out, and also there is no kinetic energy, no potential energy. So we will get the formula that Q input is equals to m dot h1 equals to m2 h2. Verse wise for energy when Q is output.
Okay, I will present about the liquid suction line heat exchanger. The function is to increase the refrigerant temperature by letting the heat flow from the condenser line to the compressor suction line. And this technology has been used to get a better refrigeration effect. The condenser suction line inlet is from the condenser and the compressor suction line is from the evaporator. As we know that the condenser and compressor have the same value of Q, which is the same value of heat transfer between of them. And then the m dot from both of these line, the mass flow rate is actually different because it has a different control volume. Then we use the energy balance equation and we can equalize the Q in and out between them, and we get the Q in and out is 24.984 kilowatt, and the T2, which is into the condenser temperature 81 degrees Celsius. Okay, does it conclude how the ice maker machine is working and the theory of thermodynamic that work behind it? So that's all from us, and thank you.